objective of this activity is to show that the parallel lines are equidistant at all the points. Let's understand the concept of parallel lines first. The two lines which we draw on a plane can be of three different types. One, they are coincident. Coincident means overlapping. So if you draw one line and you draw another line just above it, that means the two lines are overlapping or coincident. The two lines can be intersecting. That means they will cross each other. So you draw one line like this and one line like this. You say that the lines are intersecting at a point P. And the third case, when the two lines are parallel. Parallel lines do not meet. So if you draw a line like this, you have to draw another line like this. If you produce these two lines indefinitely on both sides, they are not going to meet, and therefore they are called parallel lines. So if you have a parallel line L and another parallel line M, then these two lines will have equal distance between them at every point. I mean, if you draw a line like this making an angle of 90° here and 90° here, then this distance A, and if you draw another line anywhere else like this making an angle of 90° with both L and M and this distance B, then the two distances A and B are always going to be equal, and that is the property we are going to verify in this particular activity. The material required to perform this activity include geometry box, a sketch pen, chart paper, square, grid paper. Let's perform this activity of parallel lines now.
So to verify this activity on parallel lines and the distance between them, we have taken a squared grid of paper. Here you can see the small squares. The horizontal and vertical lines are drawn on the sheet of paper to convert that into small squares. We have taken a point A here and a point B here and drawn the straight line AB. Similarly, we have taken a point C here and a point D here and we have drawn the line CD. The line AB and the line CD are parallel to each other. And now we have to mark so many points on line AB, where the points are labeled as A1, A2, A3, A4, A5, A6, A7, A8 and A9. Likewise, on CD, you can mark the points as D1, D2, D3, D4, D5, D6, D7, D8 and D9. So on a plain sheet of paper or in the observation table, you will be writing the serial number 1 and then the distance between the points which you are taking. If you take the point A1 here and D1 here, so the points are A1 to D1. That means A1, D1 is the length we are measuring using this square grid of paper. So how many segments of the line lies between these two parallel lines? 1, 2, 3, 4 and 5. 5 segments. So A1 to D1 distance is 5 units. Likewise, if you observe the distance from A2 to D2, so you will write A2 to D2 here and then measure the number of segments 1, 2, 3, 4, 5. You will find that if you take the corresponding sides, that means AB and CD, and points on them, like A1 corresponds to D1, A2 corresponds to D2, likewise A3, D3, A4, D4, A5, D5, all these distances will have exactly 5 line segments between them. So A3, D3, again 5 units. And similarly, this continues up to A9, D9, because that is the last line segment. So 1, 2, 3, 4, 5 parts, and therefore that is also 5 units. Now this proves that the distance between the lines AB and CD is always 5 units, which is a constant quantity, and that proves that the distance between parallel lines remains constant.